Hey there, eighth graders. Let's move our knowledge forward a little bit. So yesterday we did the who will win the race task and started investigating this idea of what if we have more than one relationship that we're supposed to show? You guys talked about how to show it in a table, and then you showed it in a graph. We did an equation as our other method. You guys drew pictures and submitted them to me. We're going to come back to that idea and what we were doing, but there's one more piece to this that we really, really need to know how to do. And it is on page 50. This is going to come up a lot in the work that we're doing. So everybody grab page 50, grab your pens and your pencils, and let's learn about a new form of equations called standard form. Here is page 50. This is a new form because so far this year, we have focused so much on slope-intercept form. Y equals mx plus b, y equals mx plus b, y equals mx plus b. We've done it a lot and we'll use it a lot more. It's a very, very important and useful form. Unfortunately, not all information that you're given just lends itself nicely to y equals mx plus b. So to investigate what else we might run into with this type of stuff, let's read a situation on the top of page 50. Those words are small, so I'm going to zoom in just a little bit. It says, the Hernandez family wants to eat out on a Monday night. Salads cost $8 each, and sandwiches cost $6 each. They have a gift card for $54 and want to spend all of it. This part's key right here. Let X represent the number of salads and Y represent the number of sandwiches. Okay, we're supposed to write an equation to represent this situation. That's what number 1 says. And we're used to doing that. We've done that a lot. But so far, every time you've been asked to write an equation, you've been able to look in the story, and we've always said, what are the 2 things you need to write an equation? You need M and B. Yeah, you need M and B. Well, that's if you're going to write an equation in slope-intercept form. Sometimes you read a scenario, and in this scenario, what I see is I'm used to looking for something like a rate or something, right? Like $5 per day, or the taxi place charges a fee of $5 plus 75 cents per mile. And we see that 75 cents per mile and we think M and B. I see salads cost $8 each and sandwiches cost $6 each. Those both kind of sound like slopes, but then instead of like a B value, a starting point, they have a total of $54. So what I'm seeing in this story is that it does not lend itself well to y equals mx plus b. And this is the point in class where I say, well, what do you think the equation would be? And there's always somebody that comes up with it because it makes sense, but it does not make sense in a y equals mx plus b format. Here's what makes sense. If x represents the number of salads, well, then we're going to have 8x because salads are $8 each. And if y represents the number of sandwiches, we're going to say 8 times the number of salads plus 6 times the number of sandwiches equals their total of $54. That equation makes sense in this scenario. However, that is an equation that I've not dealt with before. I'm not used to seeing x and y on the same side of the equation. I'm used to my equation starting with y equals. I know what to do if it starts with y equals. This right here, when you have x and y on the same side, and they both have coefficients on them, this is now what we call standard form of the equation. This is not slope-intercept form. It is standard form. Here's the really nice thing about standard form, though, is it can absolutely be changed into slope-intercept form. And we're going to do that a lot in this particular unit because, again, slope-intercept form is a super useful one. It tells us a lot of things and it helps us know how to graph it. It helps us know how to do a lot of things. But not every scenario starts out nicely in slope-intercept form. So sometimes they start out like this, and then we have to change them. And that's what number 2 says. Write the equation in slope-intercept form. So the first thing I'm going to do is copy the equation. Okay. Now, one of the key things with slope-intercept form is that it starts with y equals. Okay, so what that tells me is if it starts with y equals, then I need to solve for y. Okay, that means, how do I solve for y when it's all over here on the same side? Well, you know what I got to do? I got to get rid of the x term. We've done this when solving equations with variables on both sides, but now you're going to see you can actually do this to just change the form of it. Just stick with me, I'll show you. So this, I'm going to zero that out. I'm going to move the x term away. And then I'm going to do the same thing over here. Okay? Now, when I do that, I'm going to get, this is 0, and this is 6y equals negative 8x plus 54, right? Okay, now I'm going to, ooh, I have something stuck to the y. Remember what we do with that? We divide that by 6. Okay, I turned that to 0 because I wanted to get rid of the entire x term, and now I'm dividing everything by 6. That's how division works. And this is the one tricky part that we got to be careful of, is we've got to divide everything by 6. Everything. That means all those terms. So this turns to 1. Let's do these separately, okay, because I'm dividing everything. Negative 8 over 6. Well, that could be a decimal, but since I see this graph over here, and I'm probably supposed to graph it, I'm going to do negative 4/3 x. And then 54 divided by 6 is 9. Okay, now I got it in slope-intercept form. Once again, though, why did I need standard form? Well, because that's how this story started. A lot of times you'll be given a story that it doesn't make any sense to jump right to y equals mx plus b because you're not given m and b. I was not given m and b in this story. I was given what the salads cost and the sandwiches cost, and I was given a total. So this situation, it just made sense to go right into standard form. Then I took that standard form and I changed it into slope-intercept form. And now I did that. See this arrow over here? It says do this now. Now I can graph this equation because I changed it into slope-intercept form. So let's come down here. It says label the axes. That means what does x represent? Well, it told me up here, number of salads. So the x-axis is how many salads. And the y-axis is sandwiches. And I'm going to use my graphing skills because I got this in slope-intercept form. I know that this 9 is the y-intercept. So look what I do. I come up here and start at 9. And then from there, I'm going to go down 4. So 1, 2, 3, 4 over 1, 2, 3. Down 4, 1, 2, 3, 4 over 1, 2, 3. And then I'm out of room here, so I can draw this line. And this green line represents this situation. Now you can see why they didn't give it to us in M and B. That doesn't really make sense for the story. We're saying for every 4 fewer sandwiches you buy, you can buy 3 more salad. It's a weird thing to say. We wouldn't say it that way. That's why this one started with standard form. But what do the ordered pairs represent in this? Well, they represent the number of salad and sandwich combos that will cost exactly $54. That's still what the line represents. It's still solutions to this equation. It's just we started with a different form of equation. So we're saying you could buy 0 salads and 9 sandwiches. You could buy 2 salads and 5 sandwiches, or you could buy 6 salads and 1 sandwich. And in this case, that's probably all that counts, really. Maybe we shouldn't even connect the dots because maybe the in-between doesn't count in this. I don't know. That's something called discrete versus continuous that you'll learn a lot more about in 9th grade. So right now we don't need to worry about it a ton. But probably if you go into this place, you can't say, I want 4 salads and I want 3.75 sandwiches, please. They'd probably think you're weird. I don't know. Okay, so main idea is this. Standard form looks like this. AX plus BY equals C. And A, B, and C are capital letters just because they are constants. They are values. They could be any number. In our situation up here, A was 8, B was 6, and C was 54. But what happens with standard form is that X and Y are now on the same side, where slope-intercept form is Y equals MX plus B. That's one that we know very well. And that can be turned into that. But I want you to notice that the only variables that are the same between these two are x and y. Because as soon as I solved this for y, the 8 and the 6 and the 54 were not in this anymore because we had to move things around and divide everything, and so it changed these values. Now I have m and b. Again, notice too that up here, I did not see m and b anywhere. So in standard form, you're going to see the constants in front of the variables. In slope-intercept form, that's the only way you can actually see the m and the b, is if you change it into slope-intercept form. The only variables that match after that are x and y. So let's try this a few more times, because really the main idea here is this one is not super graphable. It's not very easy for us to graph because we need m and b to graph. And notice there's no m or b in this standard form because it's not there until you solve for y. So we're going to take each of these equations and we're going to solve them for y, and then we're going to graph them. So the first thing I'm going to do here is I'm going to zero out the x term. If there's an x over there and you're in standard form, get rid of that x term. Minus x minus x. Now it says negative 3y equals. I always write the x term first because I know I'm trying to get into slope-intercept form, and as long as you match the signs, you're good. Negative x plus 12. Now I need to divide everything by negative 3. Some people like to do the big bar. That helps them. Some people feel like they forget unless they separate it out. It all means the same thing, so you do whatever works best for you. So that turns to 1. Careful right here. What is that? What's really in front of this x? A negative 1, right? So if I have negative 1x over negative 3, do you know what I really have? Be really careful right here. I really have positive 1/3 x. Not 3, not negative 3, not negative 1/3, positive 1/3 x. And then 12 divided by negative 3 is negative 4. Okay, I solved it for y. Now this is totally graphable because now I have m and I have b, and I'm ready to graph this. So I'm going to go down to negative 4. Always start with your y-intercept, and I'm going to go up 1 over 3. Up 1 over 3. Up 1 over 3. Remember, the more dots you can get, the better. This is supposed to have a positive slope, so from left to right, it should be going upward. Okay, positive slope going upward. All right, let's try another one. Number 6. Here's what I'm going to do first. I'm going to zero out the x term. See how I did that? Minus 3x minus 3x. Now this says negative 5y equals. I'm going to put the x term first. Keep all the signs with it. The 3x is negative. The 10 is positive. That's what matters. Keep the signs with it. Now I'm dividing everything. Every single term. Divide all 3 of those terms by negative 5. That turns to 1. This is now positive 3/5 x. 10 over negative 5 is negative 2. Be really careful about your signs when you solve for y. That's the #1 mistake. And if you get those signs wrong, then when you try to write down your m and your b, those are going to be in the wrong places if you didn't pay attention to your signs. M is 3/5 and b is negative 2. So I go negative 2 on the y-axis, and then I go up 3. These squares are so small. 1, 2, 3, and then over 5. Up 3 over 5. And then I'm going to go back this way, and I'm going to go down 3 over 5, down 3 over 5. And now I'm going to connect my dots and show that this blue line, I want to make sure you guys understand, this blue line still shows all the solutions to this original equation. I just didn't know how to graph it until I took this standard form and turned it into slope-intercept form. I had to take the standard form and turn it into slope-intercept form. So here's what I want you guys to do right now, just to make sure we've got this and we're not just, following along with Miss McGowan, which is fine if you've done that so far. If you're like, I think I can do this, pause me right now and try that on 7 and 8. Solve it for y, get it in slope-intercept form, and then graph the line. Go ahead, pause me. Let's see how we did, starting with number 7. Actually, all you had to do on number 7 was go plus 2x plus 2x. There was nothing to divide by after that because there's already a coefficient of 1 on the y. So at that point, we have our slope-intercept form. So m is 2, b is 7. So look what I did. I started up at 7 and I went up 2 over 1. Then I already ran out of space there, so I did a bunch of times this way, but make sure your line has a positive slope. If it doesn't, make sure you fix that. Okay, look at number 8. On number 8, when I went minus 3x, that's still the step that I take. There just happens to be some x's for me to actually combine with on that side. That means this one did not actually start in standard form either. It's not standard form or slope-intercept form. Sometimes it's just something in between. But it's always a good idea to just solve for y and get it into a form you can recognize. So I'm at minus 3x minus 3x. Now I have negative 2y equals 6x minus 3x is 3x. And then I had to divide everything by negative 2. Look at my signs, look at your signs, double check things. Make sure you paid attention there. So now I'm doing m equals negative 2/3. This is a negative slope, and b equals 6. So I'm up here at 6 going, and then I go down 3 over 2, down 3 over 2. Hopefully we're getting better at positive and negative slope and getting that in the right direction. This is called standard form. A lot of the equations that you'll be given or that you'll have to write from a story, they don't always lend themselves to y equals mx plus b. So we have to know how to start with standard form and then get it into slope-intercept form so that we can still graph and work with it.